Did you try to make them feel bad about that?
No, because I asked at the beginning, I showed up early and asked the students, do people usually talk or turn on the videos? Like, no. Oh, okay. They were pretty good over text though, and at the very end, some of them unmuted and asked questions, but none of them turned on their video. Yes. So when I mute Graham, I don't hear the buzzing noise. I don't know if anyone else was hearing that, if it was just me.
No, I definitely got it as well.
Okay, cool. Well, welcome to Tuesday. Today is going to be a little depressing. I apologize in advance, but I think it is important to talk about this kind of stuff. But before we get into any of the depressing details, I would like to point out that exercise 3 is up. So that is available off of the class website, and it's an e-class. Exercise 3 is based on Anna and Andreas's task. And there's a numerical part and a programming part, and then there's a bonus part. So if you would like to do this exercise, it's due end of Saturday, not this weekend, but next weekend. So if you are planning on taking reading week off and taking a vacation, that's great. You totally need to take time off. But if you want to do that, I would suggest getting this done earlier. So I would suggest getting it done this week. And if you have any questions, please feel free to ping us.
Well, Matt, if I did 2 earlier assignments, do I have to do this one as well? No, right?
No. You need to do two exercises, and if you already did 2 and you're happy with those, you do not need to do a third. But if you think it's interesting, you are more than welcome to do an extra one. Hopefully it will be not only useful, but fairly interesting and maybe even entertaining. But if you are too busy and you've already done 2, I completely understand.
All right, thank you.
Matt?
Yeah.
So in case we do the exercise 3 as well, so you'll be taking the best of 2?
That's right.
Okay, yeah, thank you.
Yeah. All right. Oh, that's right. In the last class in Discord, so in the last class we were talking about the idea of doing these safe updates where you could improve accuracy, but things that you were doing right, you can now do wrong. So let's try to always make sure we keep doing things right. And one person was asking, it seems like this is going to be overfitting. And that's been bugging me. I haven't come up with a good explanation. I was wondering if anyone else was annoyed by this or if they had any ideas, because I'm at the point now where I think I might actually want to write the authors and try to ask, what are we missing? But I thought I'd ping you all first to see if anyone else had any further thoughts.
Do you mean, I asked this question, do you mean that you agree with what I was writing or that you disagree?
I agree. It seems like this will lead to overfitting.
Okay, all right, thanks. I don't understand either.
And based on the caliber of researchers on this paper, my guess is we're just missing something. But I would be interested to know what we're missing. So before I embarrass myself, I wanted to see if any of you had come up with any answer. Yeah, Graham.
Would you say in general that an improvement of accuracy or whatever the metric is results in overfitting? Just in general, if I go from 80% accuracy to 90% accuracy, has there been overfitting?
I don't think so.
And if that isn't overfitting, then this is just a constraint on what things need to be right.
Well, so when I think about overfitting, I think of saying, well, one way you could overfit is you just kind of memorize the data. And then when you try to generalize to new things, you do not generalize well because you've just gotten as much as you can out of this one data set. And it seems like if you're not allowed to get things wrong, it seems like you're kind of locking yourself into this thing. I don't know. I don't have a good way to explain it.
I think it gives you like an artificial local maxima for improvement, because based on some first iteration, you've kind of locked in some rules of thumb for like we are going to focus on getting the elderly patients correct, kind of a thing. And once that rule of thumb is put in practice, you can never go against it, because you can never get those ones wrong again. But I don't think that necessarily means overfit. It just it could lead to a worse, like
Yeah,
a
so-
worse best.
Yeah, so that I absolutely agree with. So if you locked in this certain population and you needed to get one person in that population wrong to get everyone else right, in the extreme case, you wouldn't do that. So you're stuck in this local optimum. I completely agree with that. And I think that the overfitting thing that Scott and I are thinking about is slightly different, but I think this is another problem I'd like to bring up. All right. Well, then I'm going to pester those authors, and I'll let you know what they say. Okay, so this was kind of long. I wanted to start off just with your impressions. So, had people heard of this before? Is this something you talked about during undergrad, or was this new? Was this surprising?
So I did engineering in my undergrad, and I did like an engineering ethics course, and they had all of these examples for all of the other different types of engineers for failures that were fatal and caused big bad problems. And every single time they talked about this one, because they wanted to involve the software engineers.
Yeah, it's not just hardware people.
But this is one of like only 2 incidents over, the past like 50 years that has resulted in deaths that is the result of software.
Huh. That surprises me.
That can't be true, because there is a helicopter in service in the Canadian Forces that has a race condition on its 3 running flight computers, and one crashed this summer because of the race condition, and it's 100% software problem.
Okay, let me amend that. At the time that I took the course, it was one of only 2, which was a while ago now. So fair enough.
Well, and so when I was working in electronic medical records, the standard always was, if your software kills someone, what are you going to do to explain to the CEO why you were not negligent? So I'm sure software has killed more people. I mean, you could argue that the Tesla self-driving car that ran over the pedestrian was another example. But whether you can necessarily blame the software is another question. So, okay, so this is a great example of software killing people. It's not AI, right? This was not a machine learning system. This is kind of outside of the scope of the class, but I think it is a really good thing to talk about. So what other impressions do people have? Or if this was the first time they'd heard of it, what did they think of this?
Well, I think it's interesting on the operator side that people just get used to, I guess, there being a lot of errors, or they kind of take it for granted that that's just how the system operates, and that we should be almost negligent to what that could mean. And that there's some interesting quotes. But yeah, there was something along the lines of like, when they did their courses, or they were instructed on how to use the machine, they basically understood that like, oh, there's enough safety checks that things won't go bad, or if something goes wrong, just click OK and continue using it, because that's just how the system works. And I guess if you're being told by someone more senior, or someone that's used it before, you just kind of take it for granted. But it seems kind of scary in the medical world, for sure.
Yeah, I didn't pull out that quote, but I remember what you're talking about, because the operator was basically saying, well, we were told it couldn't hurt anyone, which is terrifying. And you combine that with the operator has no way of actually measuring the dose the patient was given in practice, right? It's only after the person gets burned that you figure out something went wrong, because the interface just says yes.
Yeah, I just found the quote, and I think one of them was that the operator further testified that during instructions she had been taught that there were so many safety mechanisms that she understood it was virtually impossible to overdose a patient. Or the other one was that an operator mentioned, I can't remember all the reasons it would stop, but there was a lot of them.
Right. And if you could,
It seems dangerous to hear these kind of things from this kind of system to me.
yeah, and if you can just hit enter to keep going.
The
Scott?
thing I really loved was the message or the quote that said the messages, which were the error messages, had been expected to be used only during internal company development. It's like, oh man, that is the most optimistic thing of the designers ever.
Yeah, like when you get a pop-up that says, you should never be reading this. We should have fixed this error. Like, yeah, that's a little scary. Well, and you know, a lot of software developers will say that the error is between the chair and the keyboard. And if having a user error, if the user is making an error, it can be your fault. It probably is your fault. You probably need to build your software so that the user, for instance, can't kill people. But even in the less serious cases, right? When there's user error, there's probably things you could do to make your system, to make your UI better and more robust to that.
Can I comment?
Please.
Yeah. I kind of found it interesting and really bad from the programming point of view that the machine did not suspend, like they had the proceed command. And in the second case, in the Ontario Cancer Foundation, I guess, yeah. So it kept saying that, you know, there was no dose delivered to the patient, and the operator just kept pressing P, you know, and that's a very bad design, because you are literally playing around with lives, right? You need to have kind of like a stronger, basically I felt that the proceed command shouldn't have been there, and like at all, because it needs to have like I'm not sure how to put this exactly, but the machine should have suspended, like should have shut down the instant it realized there was something wrong. And yeah.
Yeah, I agree with that, because there was can't remember whether they called it suspend or something else, but there was that something's really bad, we're going to make you stop. And if you train the user that you are going to give them lots of errors and they don't matter, you should just keep going, then you can't blame the user when something, well, it's harder to blame the user when something bad happens. And it being, you know, it being someone's health. And the really scary one where, you know, they're in a different room and the intercom isn't working. So when the person's making noise and the operator can't hear them, that just must have been horrible.
It's like a setting for a really bad horror movie.
Yeah.
Yeah.
Yeah. Well, and part of this goes back to, sorry, Revan, part of this goes back to, you know, we say software engineering, but a lot of people argue it is not engineering. You do not get certified. There's different kinds of liability. It's still, some people would argue software engineering is still an art, not a science. And cases like this really bring it home. So, Revan?
Oh, yeah, I was just gonna give my impression. I don't know. I thought like a lot of these problems could have been avoided if they just did better testing. Like I think there's a quote where he says that it was tested for 2,700 hours, but then on like further clarification, it was actually 2,700 hours of use. So they counted just like all the use of the machine while they're developing as testing. And, you know, if they actually had somebody who was proficient with the machine, you know, with the data entry, one of the bugs was caused by entering in data too fast or going back and correcting errors too fast. They probably could have saved some lives if they actually had the people who are going to use the machine tested rather than the people making it.
Yeah, so that's a great point. Has anyone in this class been part of real quality assurance or testing real software? I'm seeing a few kind ofs, but not reallys. So again, this is, gosh, 2001. So this is totally out of date. But when I was a software developer, you had the quality assurance people, and they were experts in this software. They knew everything in and out, and their job was to break it. And having that adversarial, I mean, it wasn't really adversarial because they were your friends, but having this adversarial relationship was really healthy, because they would go and do things you would never think of. And then they would expose bugs and you make it better. And it's not just, them clicking buttons, but it's setting up scripts. So you stress test it. What happens when we click 15 times in a row on this button and then this other button? And unless you're doing that as a developer, you're never going to see the bugs that you write, right? Because you've got all these assumptions baked in. It's only when you get an outside perspective, someone else comes in and tries to really test it. And then the follow-up, when they were saying, well, we identified a bug, but we fixed it. Now the system is perfect. Like the hubris of that was just amazing. It was like, oh yeah, we fixed the one bug we found, so now we're sure. That struck me as pretty interesting.
Yeah, and they had weird claims too about like 5 orders of magnitude increase in safety that seemed to come out of nowhere.
I actually think that this particular system, because it's small, relatively close to the hardware, would have been a good candidate for formal verification or like formal correctness of the software, which is usually not feasible to sort of explore all the states possible in an algorithm in anything that you normally would use in real life. But for at least the parts of it that are close to the hardware, they could have done that, and then it could have been provably correct for a certain subset of the program.
So have you run across any verification, either in courses or in other things?
Yeah, I did take a course on software validation once again some time back, but you can do it, but it has to be in fairly small programs. It's an expensive undertaking. It's difficult.
Yeah, absolutely. And I like the idea of bug bounties. So you've probably seen this in that people will find a bug in software, they tell the manufacturer, the programmer about it, and then the company doesn't do anything. So eventually they go public trying to make sure the bug gets fixed, and then they may or may not get sued by that company. So the companies that go and say, please break our software and we'll pay you for it. I think that's amazing. I think that's such a better practice, but I'm not a software engineer, so I don't know if that is state of the art.
I guess one point I'd like to bring up before we move on from testing too is that when you're testing larger and more complex systems, even when you have, like I worked for a company for a short time that did this for a large advertising company. And what tended to happen is that for the more complex bugs, they say it's the testing software. They blame the testing software, and the testers blame the developers. And there's this big, ugly finger pointing circle that happens, and nobody can really prove whose fault it is.
Awesome. Yeah, because of course it comes down to assigning blame, not actually making the software better.
Yep, that is true.
Okay. So, and also I do like the comment, Laura, that you always have your kids test the UIs. I like that. I'm not sure, Eleanor can't read yet, so I'm not sure she's quite ready for it, but I guess for the visual UIs, I'd need to enlist her. Okay, so a few of the things I wanted to call out. So first of all, I didn't really understand what was going on with the difference between X-rays, which are photons, and the electrons. I understood they were doing something with cancer. Did anyone actually understand like either the physics or the medicine behind it at any level?
So the electrons because it's like physical matter. The electrons that are being struck on the patient, they can't penetrate very deeply.
Oh.
And so the radiation is generally delivered to a shallower area, but the X-rays can obviously penetrate all the way through the patient. And so using photons for radiation allows you to get much deeper. This is my very limited understanding of radiation oncology.
Yeah, I mean, my impression, I think that the critical part where there's these two forms and having these two operating modes is one of the things that seem to cause a lot of problems. Okay, so they're shooting patients with either electrons, which are light but have mass and charge, or photons, which don't. And it was on a PDF-11. So DEC, Digital Equipment Corporation. Here's an example of a PDF-11 in its glory. So this was a 16-bit machine. A successor to this machine was the 32-bit version, which was a VAX-11. And the reason I bring this up is when I was an undergrad, we had a VAX machine for email. It was awesome. We were really sad when they had to retire it just because we were so cool. Also, all of the emails and passwords were sent in clear text, which you could absolutely sniff by just being on the wired network. So that was good times. So just to give you a sense of, this is what they were using. I really like the colors though. And then here's the terminal. So they said there was a VT100. I had no idea what that was, but to give you a sense, here's the thing they were looking at. So in the paper, they did have that one kind of screenshot of what the interface was like, but here's what the operator would actually be on. So I remember in undergrad having one of my professors talk about how when he was debugging originally in college, they would print out the pages of their code that was just binary and tape it up all over the room, so that when they were trying to debug, they would walk around and figure out the program flow. So they were using PDP-11. It is an assembly language. They were not doing everything directly in binary. They did have commands, but here is a hello world. So if you took an intro operating systems class, you may have had to do something like this, where you need to think about moving things. So moving a message into a register, and then I'm guessing this is doing something with moving from register 1 to register 0. Here's an if. Then you've got these labels for go-tos. So part of I do feel a little sympathy for the programmers, because this is the kind of stuff they were dealing with, but this was state of the art, right? So you can't, just because they didn't have a visual interface, just because they didn't have the ability to checkpoint and step through their code, there were definitely problems. When they were talking about that, 5 orders of magnitude, they were talking about, and this is on page 8, they were talking about fault trees. So that's something that it started in the early 60s. I had to look this up. This is just quoting direct cut and paste from Wikipedia. Never do that. It's bad. But Wikipedia says that these fault trees were invented for things like aerospace and places where they had lots of complex systems and had hardware failures. So at the top, they would have some kind of error condition. So for instance, that the plane falls out of the sky, or something bad happens, and then figuring out what could cause that. So they've got OR gates. So if any one of these is true, they also have AND gates. If 3, 4, and 5 are true, then the AND is true. And they can go through and kind of figure out, well, if this occurs only 1 in a million times, and this occurs in 1 in 1,000, well, then there's only a 1 in 1,000 chance that this thing would cause this to happen. So I think that's where they were getting these crazy numbers. And the thing that the paper emphasized is they were doing this kind of analysis only for the hardware. They weren't trying to figure out how likely is it that this module is going to misfire. And I don't know fault trees well enough at all to understand if software could be included into this. So I don't know whether they were not considering software and they should have, or if a fault tree analysis was the wrong tool to use. But it's clear that if you're doing a medical application, you do need to have some kind of way of convincing yourself and users that things are working right. This was one way they did it to try to understand the risk that something would go wrong, and it was absolutely incorrect. The analysis did not work out, did not correlate with the real world risks or failures. And you know things are wrong or going badly when the users have to debug the thing on their own and then start hacking together hardware fixes to make the system safer. So I didn't realize that medical doctors who did chemotherapy were called physicists. I don't know if that's a normal thing.
They're not. They're radiation oncologists, but hospitals generally employ a few medical physicists that are responsible for like making sure that the machine is working. They're the ones who are in charge of procuring like radioactive isotopes, that kind of thing.
Okay, so this really is a physics, someone with physics training. Okay, so then it makes sense that I thought this was an MD who is doing this investigation. This makes more sense. Okay, so we've got, in any case, we've got a user who's like, this isn't working. The company's telling me it's working. It's not working. And it's up to them to try to figure out what was wrong. So that was scary. And then going the extra step that people realized there were problems and they were trying to add extra safeguards that weren't in the machine originally. So good on them for trying to make things safer. But it seems like at some point you would say, well, if the thing the manufacturer gave me isn't working well, should I be trying to make it better or should I be throwing it out? And of course, that comes back to what are the alternatives, right? If this is the only machine you have and you can't go back to what you were using before, maybe that is the right solution. I don't know. But I think there's some interesting ethical questions there. Yeah, Nick.
Well, in my experience, which is primarily military aviation and search and rescue, this is the norm, not the exception, where every piece of hardware that comes with a battery or uses electronics and has some software does get hacked together to make it work in the real world. Because even state of the art today isn't as good as replacing a human. So we still need trained humans in the loop, and it's still pretty normal.
Okay, so that's disappointing.
Like
but I guess
in aircraft, for instance, there's lots of things where we'll just pull a sensor out or pull a circuit breaker because the software is never going to work. It doesn't work in this condition. We are in +2 degrees and rain. This isn't going to work, so just pull the breaker. And
awesome.
and in medical situations, in the military situation, government procurement, you can't go back to the manufacturer. The process to acquire things is big enterprise, same thing. The process to acquire your technology is so complex. It doesn't matter if it doesn't work right now. As a user, you have to make it work because you can't do anything else about it at this point. And that'll be true for 5 years.
Awesome. Yeah, that's terrifying because shoot, what was the airplane that got grounded before everyone stopped flying? Boeing
737 Max.
737 Max, right. So there they had sensor problems, and there's been a lot of investigation into that and trying to figure out what pilots just kind of ignored or should have ignored. Reminds me of that a little bit.
I think it's really fascinating because it really was a combination of the software is doing more and more, and the pilots are less and less experienced. And the combination of the two. I mean, I've never been on a plane that wasn't broken in some way. The pilots just have been flying for so long, they're very used to adapting and doing all of the things. I think it's really interesting with self-driving cars, where you have right now the people. I drive a Tesla. It's fantastic. It does a lot of things for me, but it is exactly like flying a plane on autopilot, where I have to pay a lot of attention to certain things and make sure it doesn't put me in a dangerous situation. But for the most part, it does all of the work. Now, as an older person who's been driving a lot for their entire life, and I've got a lot of miles under my plate, I'm a good supervisor of the car. But once it becomes more mainstream and people are getting their driver's licenses later and later in life now, what happens once these cars become much more affordable for younger people who have maybe no driving time under their belt? And now they're driving or they're sitting behind the wheel of a car that's pretty much driving itself, but they don't have the experience to recognize danger situations. So now the software has to be that much better because the operator is that much less experienced. And I see that in this medical piece as well, where you've got a naive operator and a system that was sold as very good that wasn't quite up to the standard it was sold to. And now you end up with a bigger problem. And I think that's only going to become more relevant as we do more complex things and lose user experience.
Yeah, well, when I learned to drive, I specifically learned on a stick shift and learned how to do hill starts. And it's never come up. It's never been useful, but by golly, I did it. Would I want my daughter to learn how to drive a stick? Probably not. Would I want her to learn how to drive at all? Depends on where the autonomous driving is by that point. But that if you don't have those underlying skills, or if you just assume that it's going to do everything, that's going to get you into trouble. And in this particular case, I think the operators, their expectations were not correct because of what the company was telling them, but also because they couldn't see the actual dosage because their interface did not necessarily reflect reality. So that's kind of scary. So when you think about when a plane is flying, the pilot cannot understand everything, every tiny thing the plane is doing, but the pilot's abstraction of what's happening better be good enough so that they can make the correct actions when they need to. And that's something that was not happening here. So the user is never going to understand all the details, but if they don't have the correct understanding of how the system works or how it's functioning, then that human machine system is really going to break down. Okay. And then there are parts about the company that I found a little creepy. So on page 19, they were talking about how they said, oh, we don't know of any overexposure incidents. And they already had received a lawsuit a few months before that. And they had, I believe at that point, had investigated another overexposure. So that was pretty sketchy. Then there was okay, well, we fixed the logic. No, you didn't. Or at least if you fix this one bug, you didn't fix the overall logic problem. And then when they were getting trying to do their validation, they gave test data that showed the exact opposite of what they were claiming. Now, maybe that was just a stupid human error, but that really doesn't give you a lot of confidence in this company when they do that kind of, okay, we're going to take your machine off the market. No, really, look, it works. And you give them the wrong data like that. No, yeah, someone should have gotten fired for that. So I was underwhelmed by the actions that the company was taking. Hopefully it was, just user error, not malice or neglect. And I hope those people that sued, sorry, this is the American talking. I hope the people that successfully sued them got lots of money. I found it interesting that many of the patients sued or their estates sued, but not all. It seems like if you've got a machine that is killing you with radiation, that seems like an obvious place for a lawsuit, but maybe they're Canadian. Nope. Okay.
Okay. Something I thought was interesting with the company as well is they're actually a crown corporation. Like they're kind of supervised by the government. Like they're responsible to Parliament.
Oh, that's what Crown Corporation means? I didn't know that.
Yeah, it's kind of like under control of the government, more or less. Like they're given a special monopoly. So like that somehow made it more sketchy. Like I would expect behavior like this more from like a regular corporation, but yeah.
What, you mean a corporation that's given a monopoly should be more ethical?
Yeah, I guess that's a good point. Yeah.
Yeah, I was gonna say.
I know. I would just expect.
Oh no, go ahead.
I was just gonna say, I expect maybe they have more supervision over something like this because they're responsible to government.
I would say they would have less incentive to make things right the first time and less incentive to fix things if they go wrong, because I don't know, I feel like nobody's gonna go after them, and it's not like their company's gonna go under.
But
They also have more rules.
I think that they're told that maybe the patient's death needs not by overdose of these machines, because when you suspect this machine might not work right, but there are people telling you that there are thousands of times this machine is being used, it works normally. So you wouldn't think that maybe it's from other places, not by this machine, because a lot of people don't have problem with this machine.
Yeah, because if you're saying this machine is acting up and everyone else is saying, well, it works for me, you are more likely to doubt yourself. But if the machine kills one person, that seems like the kind of thing the company would want to tell all of its users. Because if it can happen once, it can happen twice.
I am curious with how much the software developers in AECL heard about what the actual problems were in the field. Because it does seem to me like the responses from the company are not from the developers. They're from some sort of, public relations, whatever, or not a developer. And also who they keep on calling engineers, they never give any kind of education or a qualification for these people. And the response when it was like the engineer from the main office came and he said that there's no possible way that this machine gives an overdose, to me doesn't really sound like a developer or a hardware tester so much. It sounds more like a tech that has been specifically trained for this one machine and is more just spouting like whatever they heard in the orientation video that they got. This machine's great. It never overdoses. It never does this. If this is the question you get, follow this flow chart. And this is the answer that you give.
Yeah, so it could be that the person, the tech, the engineer trusted too much, or it could be that they were following the sales pitch, and that's what they were going to say, regardless of whether they personally felt doubt or not. Okay, so moving on. Then towards the end, they were saying, well, the tests they did were not documented and independent evaluation might not be possible. Source code would not be made available. And it's not all that surprising. So this has been going on in the US. I'm not sure if people in Canada have heard about it a lot, but there's been a number of cases where people have said people get pulled over, blow into a breathalyzer, and then get thrown in jail or convicted for driving under the influence. And people are making arguments that the software in these breathalyzers are faulty. And the other things can be wrong with them too, like they're not correctly calibrated. They haven't been calibrated recently enough. But some people are making the argument that no, the software has bugs. And it's really hard to go to someone's closed source program and prove or disprove that your circumstance was subject to a bug. So in this case, they actually got access to the source code and they found some flaws. they started talking about it, and then they got threatened with a lawsuit. So yay, America. But it's scary when these, so in this case, I mean, breathalyzer isn't life and death, but it really can have a pretty huge impact on your life and your ability to keep a job. And if you can't know whether the test is reliable or not, that's a little scary. Okay, so then I wanted to end with that there's kind of this laundry list of things that we should have been done different, or things we could do in the future. So because here we're talking about human AI systems, I think the overconfidence is really pretty critical. And this has come up in a few of the things that we've read and talked about, that if the human understands the AI and understands when it's going to do things right or wrong, they can compensate. If the human, as in this case, was just saying, I'm going to trust the machine, that can cause huge problems. Another thing was the defensive design. I don't think I'd heard that term before, but my understanding was they're saying, look, there are going to be bugs in a complex system. You need to make sure that when there are bugs, they happen, or the system fails in a way that doesn't kill the people. I mean, it's kind of obvious when you say it that way, but for one of the examples they gave was the operators were shown one thing on the screen and it was not what the machine was doing. And that's pretty scary. It seems like the operator should always know what is happening and have a way to understand what really happened, not just what they entered into the system. Oh, yeah. So one person asked, why couldn't they prove the breathalyzer worked by testing it on actual drunk and sober people? Yeah, fun. I imagine that would be a fun experiment for at least one of the two groups in that controlled experiment. I think one of the arguments was like, oh, well, when it's below this certain temperature, or so that it's these kind of corner conditions, which is exactly what we were seeing here. So the Theric 25 was tested in all these different ways, but they didn't exhaustively test all the possible conditions, which you often can't. So it's when something bad happens, hopefully you fail in a reasonable way, but then you go back and figure out why did the software act this way, and how can we make sure it doesn't happen that way in the future. And then they didn't do a good job of fixing stuff. It seemed like they were just patching bugs, not actually fixing the overall system. The company really seemed complacent. When I was talking on this slide, it seemed like they really could have done a better job of handling and fixing these problems. The risk assessments we already talked about, they didn't do a good job investigating. And then just general software engineering. The author had a bunch of suggestions and criticisms about that. And that to me is kind of scary. And the reason it's scary is because when I think about AI and learning systems and how much more brittle and less interpretable and less understood they are relative to normal software engineering, when I think about those systems, if we can't deploy bug-free software solutions now, when we make them learning, how much harder is that going to be? Hopefully I'm just being pessimistic, but I mean, I guess the optimistic way to phrase it is humans don't make perfect systems, so you want the machine to be able to learn to compensate. But I don't know if that's a reasonable pitch. Okay, and three things I did want to call out. So there was the reliability versus safety. So thinking that, well, something happens over and over again, so that's good. But with safety, you really need to think about all the corner cases. So one of the things that happened in the 90s was this floating point bug, which cost Intel $750 million, the equivalent of 750 million. And of course, and that was just the replacement cost. It was a huge hit to their reputation. So after that, ARM went to, the reason I know this story is they went to professors at UT Austin, where I was a graduate student, and they said, can you go and validate our floating point? I think they were doing multiplication and division. So they were able to go through and prove that, if you make these assumptions about the hardware, you will always get, if you make these assumptions about the hardware and the inputs, you will always get outputs that match to the specification. And we were talking about this earlier in class. Like, it seems like this kind of stuff that's close to the hardware is exactly the kind of things that you would want to validate. So I believe they do this in aerospace as well for airplanes. There are certain modules and components that they fully evaluate. And it's either impossible or impractical to do this in many cases. But when you have a really mission critical thing, it can be worth doing this extra step. And this is still an active area of research, trying to be able to better validate systems with less human intervention. So getting AI to be able to validate. I believe it's kind of similar to theorem proving. So trying to have AIs automatically write theorems to prove different kinds of statements. And then, sorry, another depressing example. They were also talking about friendly UIs. This UI was not friendly. Another example of an unfriendly UI was the Aegis system. So this was from the late 80s, where the US Navy shot down an Iranian passenger airplane. So there's, again, quoting Wikipedia, because that's the best source. Sorry. But Wikipedia, and this is what I read in other places too, say it's not clear exactly what the root cause was. Of course, the Americans blame Iran. Iran blames Americans. My personal feeling is the U.S. really screwed up. And the Scientific American said their claim was that the UI was the main cause. So the software gave an on-screen identifier to the passenger flight, and then they gave an incorrect one to the old tracking number to a fighter jet. And then when the captain asked for the status, he was told the passenger plane was a fighter and descending. So the captain asked a very clear statement for a very clear question, and he was given an incorrect information. And that's this argument is it was because of the UI, a bug in the UI. And there are other things that went wrong too, but this is one of the places where, having a poorly designed UI had very real consequences. And it's mostly going to be a UI if you have a human and AI working together, that UI is going to define how they can interact and how they can understand each other. And if there are flaws in that, then you're going to be in trouble. So I wanted to just kind of drive that point home, because I know very little about UIs, but user interfaces, but I do know they're important. So if I were working on something that would, shoot missiles, it seems like you would want to make sure that's working correctly and consult with people to make sure it's understandable, does its job, works quickly and effectively. So disappointing. But it's a military system, so I'm sure they duct tape something together anyway. And the last thing was the author also talked about oversights and standards. So the medical machines are evaluated, but one of the outcomes of this fiasco was now that the regulators are started paying more attention to software. So many people, including the Brookings Institute, people at the Brookings Institute, are saying that AI needs these kind of oversights and standards. So for instance, maybe we should talk about how facial recognition can and should be legally used. I know it's being used a lot in the US in ways that I really disagree with, and other countries are using it in ways I disagree with. But I think it is something that reasonable people could disagree about what's reasonable, and just leaving it in the hands of companies might not make sense. Similarly, we've been talking about bias and explainability. If you've got a computer that's making loan decisions, if you've got an AI that's deciding who gets a job, you better be sure that it's not Amazon's AI deciding who to hire because it was fed a biased data set was recommending hiring men and not women. And if that's what your AI is doing, maybe there should be some regulations against that. I don't know. I'd be curious what other people think, because on one hand, regulations mean things could go slower, things will be more constrained. But if you have regulations, hopefully bad things are less likely to happen. I'm not sure.
So I think one of the big problems with any kind of regulation in regards to this is that there's no global regulator. So even if you make a law in the US and you make a law in Canada, it doesn't mean that other places can't go and then take advantage of the fact that we can't proceed quickly to do their own things. I think you'll see examples of this that will come out if we do get that kind of oversight, right? Whoever is willing to do what needs to be done to make it work is going to proceed differently than the ones that are trying to do it carefully and properly.
Yep. So there's the argument that the first one over the finish line is probably pretty important. And even if you're doing it the right way, if someone else beats you doing it the wrong way, that could have consequences.
I guess you could hope that, like with perfectly designed legislation, if your software had biases and it didn't hire as many women, for example, that you would probably outperform the software if you did it without bias. So with really good regulation, you might be able to avoid that. But I don't know, putting a lot of faith in there being really good regulation is kind of an oxymoron.
Yeah, well, the simple way to do it is if you have a bias system, maybe it helps you, maybe it hurts your company. But if the penalties are large enough, then it will always hurt you. So if the fines imposed make up for that. But yeah, it's unclear how easy it would be to construct regulations and legislation that would do this in what we think would be the right way.
Yeah, who would create the regulation? If you watched the U.S. Senate hearings with Facebook and Google and Amazon back in the spring, the regulators clearly didn't understand what they were talking about there. Their second round, much better, but it took a year to get there. How many years will it take to make regulation for yesterday's technology that isn't even relevant today? How would you do it?
Yeah, and the argument that things are changing so fast. Not that long ago, there was a U.S. senator that was talking about the internet is like a big tube, and sometimes it gets clogged with too many things. The legislators are not necessarily the right people to write this stuff, so they need to have technologists involved. Absolutely. But then once they finally get something out the door, it could be obsolete anyway.
And what do we really think about bias? This word is a really tricky word when it comes to how I imagine these things in my head. And I think the easiest case is for something with vision. So if you're designing some facial recognition vision program, people come in so many different shapes, sizes, forms, colors. You'd have to present every possible example to it so that it could be not biased, which I think in my head, like intuitively, that sounds totally impossible. So in a way, any kind of system that tries to recognize any kind of person is going to be biased.
Well, that's a great example, because just 2 days ago, I was reading about in the shift to online learning, there are all these new proctoring systems. Well, in the US, there's a bar exam. I think it's given once a year. It's or twice a year. It's fairly rare, but you sit for the bar exam and then you can become a lawyer. It's one of the steps. And this year they're doing it virtually, and the camera has to visually identify you. And people who are Black, Asian, Latinx, and a few others have an incredibly high failure rate. So they interviewed this one guy who said, look, I've tried 60 times. I've sat in different rooms of my house. I've tried different lighting. I've tried different camera angles. And he is potentially not going to be able to take this test because the training data was not representative of him. So every system, every machine learning system is going to be biased, right? Your machine learning algorithm has bias. The question is whether it is a reasonable bias or not. And if it's biased so that if it disadvantageous disadvantageous to one group versus another one, that could be something that you care about. But I think, Tobias, your point is absolutely right, that the data set, the training data is never going to be perfect. And there's always going to be someone who gets the short end of the stick. Was that kind of your point, or am I mangling it?
No, that's pretty much it. I mean, you can't account for everything you're going to see. There will be rounder people, shorter people, taller people, and you just can't have all of the possible variations present in the data.
Yeah, that's very true. Well, and even if it is biased, how do we know it's biased? So how can you even know if Amazon was making a bad hiring agent? And so, for instance, I think we mentioned this before, that Google has patented Dropout. So if I'm using Dropout and Google wants to sue me, how are they going to know I'm using it? So hopefully there are ways of testing and explainability and transparency so that a company can proactively show that they are not biased, or that the government agencies have the right tools to investigate whether something is fair or not. Oh, I like that. And then there's the idea there could be a market for systems that aren't biased, because if the system is not biased against women, it's probably going to do a better job than a system that is. So yeah, if we could have market incentives, that's awesome. Okay, so now I'm going to go for a different kind of depressing, because this was fun. Let's see. So I think we mentioned this before, the moral machine. So what should the self-driving car do? It could either go sudden brake failure. The car could go forward and kill one large woman. Interesting phrase. And the woman is crossing against the signal. In the other case, the car will swerve into the barrier, killing one large woman and one elderly man. So I am now launching a poll. Would you like the left scenario, where you go straight, or should the car, in the right scenario, should this car swerve into the concrete barrier?
I've got one clarification question.
Sure.
Are we to presume that striking the one large woman in the crosswalk stops the car and stops any further bad events? Or do we run over that lady and then perhaps run over a group of school children later?
That's a good point. I think here you're assuming that there's this one transaction and then you're done. So you kill the one large woman and then the car regains its brakes. So let's make that assumption. Okay, so now we're going to end polling, and it
Where's
looks
the poll?
so let's see. 10 people saw the poll, but I guess not everyone did. And I think if you're on the web version of Zoom, you might not be able to see it. Yell out again next time. We'll do this again. We'll start up another poll. So the 80% of the people said we should go left. That's what I would have done. That's what I would have suggested the car do too. What's your reasoning though? What's your justification? Anyone want to share why they prefer the left?
I'm a
There's
pure
couple of
utilitarian.
reasons. One is that she's crossing against the signal and she's in the wrong, and the other is that it's 2 lives to 1.
Yep. Any other reasons?
Just straight utilitarianism.
And what does that mean?
It means that I'm going to choose the less people dying in every scenario. I'll be consistent.
Okay. Yeah, this is absolutely related to the trolley problem.
I think it's a little also of rating the user of the machine maybe a fraction higher than other people in some way.
What do you mean? So we've got these two users, the one large woman and one elderly woman. And are you suggesting that if it was two men, someone might think differently about it?
No, I'm saying so if it was just equal 1-to-1, there's one woman in the crosswalk, one woman in the car, elderly woman is no longer in play, I still say go left.
Because
I'm not entirely sure why, but you kind of want the machine that you are using to value your life.
Yeah, so you might think that if I'm going to buy a car, if it's a toss-up, I'd rather have it not kill me. Mm-hmm. Also, I'll point out that the woman will cause a whole lot less damage than the concrete. So it's in the car's self-interest to use the left scenario. Any other thoughts before we go to the next one?
Maybe it would be better if it went into the beam and killed the 2 people, because if you kill the woman on the street, there's legal recourse that would follow. And wasn't there some case where the people behind the car were held legally accountable for murdering the pedestrian? So in a way, it might be better for the passengers to die, because then maybe they survived this crash, but legally afterwards, their lives are ruined anyways. So.
Well, and I don't know if this is true or not, but I've read in papers that there are laws in China where if you injure someone, you have to compensate them and pay for their health care. Whereas if you kill them, you don't. So there are incentives that if you hit someone, you back up and go over them multiple times to make sure you're not paying those.
The other factor in the scenario is the right action swerving into the barrier is a drastic action with an unknown. I mean, we've given a black and white consequence, but there are no black and white consequences. There's a good chance you cascade off that barrier, hit the woman anyways.
Yeah. So in this case, we're assuming we know the consequences, but you're right. The right probably has higher stochasticity, higher variance. The other argument people commonly make is, well, in the left case, you are not making an intervention. You are just going straight. Whereas in the right case, you are making an active decision to do something else. So maybe in some sense, that's worse. So let's try this again. So I'm going to stop share. I'm going to relaunch and I'm going to continue. Is that right? Yes. No. Let's see. Maybe I can close it. There we go. Now we're relaunched. Okay, so now let's see. On the left, we kill 3 homeless people and 1 woman. And on the right, we kill the 2 people. Oh, we kill all 4 of the people in the car. 2 female executives, 1 male executive, and 1 man. Okay, so do we go with left or right? This one to me is much harder than the previous one.
It looks like there's no don't walk sign here anymore. So it looks like the people aren't going when they're not supposed to.
That's right. I think these are law-abiding pedestrians, not those scofflaw jaywalker in the last example.
There's no coin flip option. That would be my pick here.
Nope, you got to make a decision. All right, I'm going to cut us off and share the results. And okay, so now we've got 5 people for left and 7 people for right. And you could think about the number of people. You could think about the class of the people. None of these people have race, but that could factor into it. In this case, they're all adults, so that's something else. But you can see this is a good example of people likely have different preferences. So in addition to being fun in a really dark kind of way, I wanted to bring this up because so this is moralmachine.net, and they did this huge study. And what they found is that people do have different preferences. So for instance, if there is a stroller or a girl, you are much more likely to spare them. Pregnant, male doctor, male executive, than large people. Yeah, so overweight people are a little bit lower. Homeless are worth less. Old are worth less. Cats are right down. Ooh, dogs are more important than criminals. Ouch. So you can see that people have these different biases, and they also do a regional analysis, and they look at how the biases are different in different parts of the world. So if you have not read this paper, Moral Machines, I think it's a fun paper that you should check out. And this whole, yeah, that's that. Wow. But you could make the argument. Well, so there's a few reasons to do this. One of them is it's kind of interesting. But another is to show that yes, different people have different preferences, and maybe the car should try to respect that. Or maybe if we don't know that, if we don't actively think about this, our AIs will not represent our preferences, and they probably, it is something that we need to do more research. Oh yeah, that is interesting. That it seems like men and women are basically even, and not everywhere, but pretty close. So I guess overall, there's not so much sexism in the moral machine. Okay, so now in the remaining 13 minutes, I wanted to talk about a TV show. So have any of you watched The Good Place? Yes, I'm seeing some nods. Awesome. Okay, I am going to, if you haven't seen it, I'm going to explain the show in like 30 seconds and ruin like the first, it's not a huge spoiler, but it could make you less excited about the first 2 episodes. So if you want no spoilers, turn off your sound, and I'll wave when we're done. So in The Good Place, these people died. Well, these people died, and they go to heaven, and they find out that they rewarded, and they get to do all this cool stuff. And then you find out that actually this guy is a demon. This is not the good place. They're in the bad place. And okay. So now that we're spoiler free, then the rest of the show, it's 4 seasons. I think they're 30-minute episodes. I found it hilarious. This show really talks a lot about ethics and philosophy. And I'm so happy a modern successful TV show is mentioning Kierkegaard and Aristotle. I mean, I think that's awesome. So if you are interested at all in ethics, that's something you could check out. But we already mentioned utilitarianism. So I just wanted to go through the kind of 3 kind of categories of ethics, just to make sure you've heard of these. So the first one is the consequentialist. So this is really utilitarianism. You're looking at the outcomes. So if we think about the number of people killed, or maybe you could sum together the expected, the life expectancy of all the participants, or something. You've got some kind of metric, and then you just figure out whichever one is better. But what do you decide is good? That can be kind of arbitrary. Who's the primary beneficiary? Does that matter? Does it matter who's going to be better off? And then who's actually making this judgment? So that can be a bit harder. Also there's the nice comments on Discord. One of them was saying that most people care more about their own life. So if the car decides to kill them, they'll probably switch to human driving mode at the last second. I like that. So the car could show a big, I'm going to kill you now. And then you could, I'm sorry, Al, I'm afraid I can't let you do that. And then, yes, the comment about classist versus sexist. I did notice that too. Awesome. Okay, so there's consequentialist. Then there's also, clicking on the screen, there's also deontological or deontology. And this is the rightness or wrongness of actions themselves. So if you give a kid a candy bar and then they die because they have an allergic reaction to peanuts, consequentialists would say that's horrible, you just killed someone. Whereas the deontology argument could be you were trying to do the right thing, you were trying to be kind, so ethically you're in the clear. So that's another way you could argue about ethics. And a third way is to think about the actual actor. So not the action, so we've got the outcome, we've got the action. That's not how you spell action. And then we've got the actor. So this last one is a little weird, but thinking about what is the best thing to do? What is a good person? What's the kind of thing that a good person would do? So for instance, let's suppose that someone needed help. Then utilitarian would say, well, I'm going to help them because that's going to maximize their well-being. The deontologist will say, do unto others as you would have them do unto you. It's the right thing to help someone out. It's the good thing to do. And then the last one is saying, well, by helping, I'm going to be a charitable and benevolent person. And that's the right thing to do. So in this case, they all agree. And in other cases, you will get disagreements between these different ways of evaluating. But even if you can very easily get two people that are strict utilitarians and they come to different conclusions. So that's always a risk, of course, but it's ethics is a framework where you can start thinking about this kind of stuff. And what we were doing with the moral machine is specifically applied ethics. So trying to say, is this thing good or bad? Or what causes it to be good or bad? Or how could we make it better? And you can have very good and logical people come down on opposite sides of probably all of these. But it does give you some kind of a framework to at least start to think about stuff. So remember at the beginning of the semester, Corey was saying, you really need to go over the possible outcomes of your system. And as you think through those possible outcomes, trying to wrap your head around the ethical implications of that. So when you're thinking about, so a concrete example is I am working with a company that is doing a project for a military organization. There are many situations where that would make me uncomfortable, but because of the organization and because of the particular project, I am personally fine with it. So it's a project I would never make one of my students work on. That's got to be completely voluntary. But it is any of my research, it is possible that some of it could be used down the road to do something that I find ethically reprehensible. And even if I have no control over that, it still in some sense comes back to me, right? Because if I did not do this research, it wouldn't have happened. Well, and then I think it was Tobias earlier was saying, well, it's whoever crosses the finish line first, right? So if Matt doesn't do it, I'm sure Nick is going to do it because Nick loves killing people. Sorry, that was mean. So part of this too is weird for me because like my wife has a bunch of military in her family. I do not. So we get into these interesting arguments. Anyhow, so ethics is a frame where you can think about this stuff. But I did want to emphasize that when you're doing this ethical evaluation, that is different from rational. It could be different from rational decision making. So normally in AI, we try to make rational decisions. And typically you define rational as your expected utility. So this is very much the first situation, very much a consequentialist outlook. And if you can make someone happy, if you can make a bunch of people happy by killing a small dog, it's totally fine. The happiness outweighs that one poor animal. So when we think about what are we going to do, if you say, should we work on autonomous weapons? Should we work on robots that can fire live rounds without human input? I think we can all come up with lots of reasons that's a bad idea. I bet many of us could come up with reasons why that could be a good idea. And once you had those pros and cons, then you could argue about whether this research was rational. You could argue about whether it was ethical. And then ultimately, if you were considering whether you wanted to work with this company or work on this research, hopefully by going through this, you would be able to make a better decision for yourself, whether this is something you felt okay with. At least that's my claim. But I worry that we as humans are not that rational, that we find ourselves in situations where there's a cool problem and I'm going to work on it, or I need to eat, I need funding. If my professor is going to give me money to work on this thing, I'm going to do it. And I don't know. I'm not sure if this is too much wishful thinking, that whether people actually go through and think about the consequences of their actions, or in our cases, the consequences of our research. But I'd be really interested if people had any thoughts about this. Kind of a big question, sorry. Scott's muting and unmuting. He's not sure if he wants to say something.
I'm like thinking about how to make the response. It's like I can't describe what I would do if I were perfectly rational, but in principle that would exist, and that for all of humanity you could maybe come up with an averaging, like expected utility function that would take into account all of humanity's values perfectly. And so you may be able to pick the correct answer in principle, but that may just not be knowable in practice.
Yeah, at NP hard to compute.
Are we just talking about the pros and cons of autonomous weapon research right now?
In general, that if you need to make, we make decisions constantly that can have ethical implications. Do people generally actually think about those implications, even for the most important ones, or do they just go with a gut feeling or not even notice?
I guess just speaking for myself, I don't really think about the ethical repercussions of what I work on, because I don't really think anything I work on is really that important. I mean, my last project was moving robots with neural networks to points, and I don't really see how that could be really weaponized in any way. But that's also because I'm not thinking maybe 5 steps down the line where now it's reaching towards points where there's a gun, and now it's that's like 2 steps separated from my immediate work, though, right? Yeah.
Yeah, and when NeurIPS instituted the requirement of an ethics statement, a number of people said, "This is stupid. I'm just doing math." But the counter to that is, well, I talked to a few people who worked in vision, and when they were doing all this vision and face detection and recognition in like the 2008, 2010, none of them, at least of the ones I talked to, none of them ever considered how that could be used to repress people's rights in a surveillance state. That just was not an outcome they even thought about. And I think that failure to imagine what could happen with your technology is a suggestion that we as researchers and innovators need to be poked to make us think about possible outcomes. But very smart people fall on both sides of the spectrum and disagree with what I just said.
But I guess kind of in line with that point, like for the people who are doing maybe more theoretical ML, the like number of steps to get to killer robots is a little more abstract as opposed to the application, more applied research like facial detection. And so I could see, for more applied, experimentally driven things, where you define some new loss or new architecture to detect faces better, it makes more sense to me to require that kind of, ethical statements or whatever. Whereas like a guy proving a tighter convergence bound for Q learning or something, I mean, like maybe it could lead to faster robots that learn how to shoot people faster kind of thing. But it's like so many steps and still like, those applied work to kind of get to that. Oh, because of faster confusion, like it's probably the next paper where they should start thinking more ethically, where it's like, oh, using this faster Q learning convergence, we have the killer robots faster now. But again, that's still more, from my view, more applied things. But I don't know.
I'm not sure if you can make such a clear distinction. Like, what if, for example, you came up with a new form of math similar to the invention of calculus, and it would allow you to create a nuclear bomb with $10 of material that anybody could acquire anywhere. And the number of inferential steps from going to that calculus to just applying it is on the order of like 1/10 of Project in Manhattan or something. So doable by a couple people in their backyard potentially. You might know that in retrospect, like hindsight might be 20/20 there, and you might seriously regret coming up with that knowledge. There's actually something called coherent extrapolated volition that tries to deal with this. And a lot of what we're talking about also applies to a lot of the work on existential risk with super intelligent AIs. So if anybody wants to nerd out with me about that, we could do that later.
Awesome. So we are actually 2 minutes over. So I'm going to turn off the streaming and recording. But if anyone would be interested in talking about this some more, I'd be happy to stick around. I think this kind of stuff is interesting and important, and I'm not sure we actually do it enough in computer science. Are we still live? I can't tell. I think I stopped recording.